Hello and welcome to the Department of Healthcare Access and Information, or HCI, 2022 CBSE Triennial Code Cycle Updates presentation brought to you by the Building Standards Unit here at HCI. As you may know, California amends its building standards every 3 years, so hold on tight and prepare to learn about some of the changes that have been made to the 2022 California Building Standards Codes. This is the first session in a three-part series, which we're going to go over the structural, which is part 2, volume 2, part 3, electrical, part 4, mechanical, part 5, plumbing, and part 10, existing building code today. If you haven't done so already, feel free to download the handout under the handout section of the Go-To toolbox there on your dashboard, and you can follow along the presentation as we go through the presentation as well. We're here for about a 2-hour presentation, which is going to include some sessions, some question and answer sessions after each part of the presentation. So go ahead and type your question into the question section of the Go-To dashboard there, and we can go ahead and answer those questions specific to each part after the end of each part as we present the information. Please keep your questions generic, and if you have a specific question, send your question over to regsunit@hci.ca.gov. Again, that's regsunit@hci.ca.gov. If we experience transmission difficulties, we're going to go ahead and ask that you log off and log back in using the same information that the Go-To software sent you, and we will do the same if we experience transmission difficulties on our end. Today, for presenters, we're going to go ahead and introduce Mr. Jamie Schnick. He is a senior electrical engineer and technical lead here at HCI. We're going to have Mr. Larry Enright, senior mechanical engineer and technical lead here at HCI, Mr. Roy Lobo, principal structural engineer, and myself, compliance officer here within the inspection services unit at HCI. I'm going to go ahead and present a couple of slides at the beginning, and the rest is going to be up to the technical team. So again, thank you for joining us, and without further ado, we will go ahead and begin our presentation. So today, as I mentioned, we're going to go over a brief introduction, and we're going to go over part 2, volume 2, structural, part 3, electrical, part 4, mechanical, part 5, plumbing, and part 10, existing building code. Session 2 is going to be held on October 27th, 2022, going over the building code, fire code, and then session 3 is going to be December 1st, 2022, going over the California Administrative Code, part 2, volume 1 of the architectural portion, and then a little bit of what's coming up, and we'll be answering more questions during that session as well. For those that don't know, this is the timeline for the 2022 code cycle. It was first published back in July. During the triennial code adoption cycle, we get the 2021 International Building Code, and then we make the California amendments to each part. We take and pull all of that together, and we publish them in the 2022 Building Standards Codes. Today, we're going to be going over some major highlights and code changes to the structural, electrical, mechanical, plumbing, and existing building. During the intervening code adoption cycle, this is very similar, in which state agencies submit proposed changes to the newly adopted codes. They go through the state agency workshops, public comment period, commission meetings, and when approved, they are initially published in January and become effective July as well. This is some more information. We're going to go over volume 2, major changes, electrical code, where we're going to mention some housekeeping items and alignment with the CBSE and 2022 NEC, some mechanical code items, alignment with ASHRAE 170, and plumbing code, more housekeeping items, and existing building code SPC 4D. There are a couple of editorial items we want to keep in mind as we go through this presentation, where we're going to go ahead and we've identified the underlined blue text as new text, underlined red text with new emphasis, and strike through is to be deleted within the code as well. And then purple text within this presentation is references as well. So that's all I have for now. So Jamie, if you're there, I'm going to go ahead and hand the presentation over to you.
Thank you, Cesar. Good afternoon, everybody. Our first amendment, this is taking Article 100 on definitions, and we're adding the definition of coordination for OSHPD facilities. Initially, we had a note for this, but the model code was changed for selective coordination to mean full range of available overcurrents. And we've added our OSHPOD coordination to allow for the 10th of a second criteria. Next slide, please. Next, we're talking about the requirements for approval, and we've revised this. Generally, this first bullet, equipment is approved, listed, labeled, is in our note. We've added a bullet, when field evaluated, equipment is evaluated and labeled by the field evaluation body. That is accredited by the International IAS in accordance with NFPA 790. And then the third one is just a reminder that the equipment has to be special seismic certification as defined in the building code. Next slide, please. Space is about electric equipment. This was simple. We just added a pointer into the building code that identifies for equipment over 800 amps. The door needs to open in the path of egress and be provided with panic hardware. Next slide. This was a cleanup, essentially the model code or our previous note called emergency, and we actually renamed that to essential to align with the CEC definition of essential electrical system for hospitals. Next slide. So this one is, I think, something that people are going to really appreciate. Essentially, we're changing the requirement for switches to be outside of 5 foot from the edge of the bath or sink in the bathrooms. We're changing that dimension to 3 foot. The reason we're doing that is because the model code identified this as a distance for receptacles. We carried that same distance for switches and at 5 foot, and now we're going ahead and revising that to 3 foot to match with the model code. This should allow for switches to be located in patient restrooms or bathrooms. And then the two exceptions are essentially allowing that nurse call can be mounted within these locations, so that the pull station at the toilet and the pull station at the showers can be installed. This matches FGI guidelines, and the requirement for these devices is to be weatherproof listed. Next slide. So then this is the receptacle version of that. We're now, you can see in the model code at the top, that 3 foot dimension is identified for the distance of the device from the bathtub ring, and we don't need our addition on the bottom. Next slide, please. This is just housekeeping. The IES does not keep up, update the IES handbook anymore. So we're using their RPs, which they keep up in current, recommended practice for hospital and for the visually impaired. Next slide, please. This is simply clarifying and simplifying that for psych facilities and SNF facilities that don't have critical care, that you only need a type 1 essential electrical system. So the category 2s could be a type 2 emergency system. Next slide, please. So this is 51730, it talks about source of power for emergency, and we have a 1.1 that identifies the allowable sources, and we'll go ahead and adding in the batteries to match as an acceptable EPS to match the model code. We have a pointer that talks about the requirement for CMS for batteries on premises, and then We also include a requirement if the batteries is your EPS that a connection will be provided for a portable diesel generator. This is similar to requirement that we see in the model code for fuel cells. Next slide. This is just the CMS documentation that talks about the emergency power system. We can go to the next slide, please. This was just a cleanup. Essentially, we're revising to only OSHPD 1 and 4 for location of the emergency power source to be in a outside of hazard areas, and we're eliminating that requirement for type 5. Next slide, please. So receptacle and switch identification, essentially, we cleaned up, moved the OSHPD banner up to the start of this description behind receptacle, and then added the provision that you can either label the cover plate or the devices themselves. So this is where red devices could be used to identify emergency power. Next slide. This one is essentially adding back into the code something that was, we feel, in error taken out of the model code, that a 10-second minimum interruption before life safety and critical are brought back on board. We expect that the model code will pick this up in their next go around. Next slide, please. So this is a new one that I think everybody needs to be aware of. We've added under the critical branch the requirement that the imaging room containing imaging equipment approved by licensing agency for diagnostic services of emergency trauma patients. So this would be one imaging room only that supports the ER, and the lighting and receptacle are needed to be circuited to essential power. And if you look at the last sentence, the imaging equipment itself will need to be connected to either critical or equipment branch. Next slide, please. This is where we are removing the requirement for the UPS to be connected to the equipment branch. Typically, these UPSs are used for telecom, which the code requires circuiting to the critical branch. So we're just cleaning up some language in our OSHPD component. Next slide. This you'll see, it's 51744, which is addressing SNFs, a limited care facility. It has an incorrect reference that's highlighted in yellow back to 51735, which is requirement for hospitals. So we've added the OSHPD amendment that the equipment branch shall be installed and connected to power as described in 51744A to correctly put this back in the SNF portion of the code. Next slide, please. This was just a correction. As the code evolved, the two branches used to be life safety and critical for SNFs. Now it's life safety and equipment. So we're just bringing this in line. You'll see 3.1 on the top, 3 on the second sentence from the bottom. It says critical. We've just changed that word to equipment branch. Next slide, please. Power over Ethernet. So this is something that there had been lots of discussion by some individuals, and we appreciate everybody's input. We are now clarifying in the code that the class 2 circuits that transmit power and data for devices do not need to be mechanically protected. So we see that the model code is going in this direction. We see that nurse call and fire alarm are power over Ethernet systems that do not have the mechanical protection. So we've just brought the the lighting, power over Ethernet lighting to match that. Next slide, please. Changes to the nurse call system. On the top, we're just adding in that there are different nurse call requirements described. 1224 is for OSHPD 1, 25 OSHPD 2, 26, 3, 4, and 5. And then on the bottom, I think something that should help everybody out, we've revised the location of the BAS stations. They used to be required to be within 3 or 4 feet of the ground. Now the new requirement is to maintain a clearance of 12 inches above the horizontal grab bar. We had some conflicts of meeting this code previously, and so we've adjusted it accordingly. Next slide. This is a simple one. Essentially, we have a requirement to keep electrical equipment that doesn't belong outside of the technology and telecommunication rooms. We're adding in raceways and cables as well. So if the raceways and cables do not report back to the telecom room, they're not allowed to be routed through the telecom rooms. Next slide, please. This is a simple modification that essentially for testing of generators, we've removed the requirement to test generators for type 1R, and we've added that requirement to the acute site facilities. Next slide. This is transfer switch. The model code has revised to allow that all transfer switches, including medium voltage transfer switches, should not be permitted to be reconditioned. And so we're taking out this portion for the 1000 volt. No change, it's just updating to match to take into account that the model code was revised to address these medium voltage switches. Next slide, please. Storage batteries. Essentially, we're adding in the runtime for the storage batteries to match the runtime that we see for emergency generators for the different OSHPD facilities. Next slide, please. On this, essentially, we are pointing out that for the generator, that the designer should be aware of the CMS regulations for on-site fuel storage requirements. Next slide, please. Again, this is a CMS code that has that requirement. Next slide, please. So this is for the fuel cell, and essentially it's just a little cleanup. This 700.12D is the correct code citation that identifies on-site fuel storage for the various OSHPD type facilities. Next slide.
Right, thank you, Jamie. That concludes our electrical portion of the presentation. Again, as we briefly mentioned during the introduction, you will have a question you will have an opportunity to ask a question by typing the question into the go-to question box in your toolbox there in your dashboard, and we will go ahead and read off the question and hopefully have the technical expert, technical lead answer that question. We have one question from a person that says, will slides from today's presentation be available? As we mentioned earlier, yes, they are available, and they are available under the go-to dashboard under the handout section. So you can go ahead and open that up and download the PDF copies of this presentation for you to follow along and make notes on. So I will give the time another about minute to have you type in a question if you have a question. If not, we can go ahead and continue with our presentation. So again, I'll wait 1 minute. I don't see any questions being asked in the go to question section. So if we don't have any more questions, we can go ahead with the next series of presentations, with mechanical and plumbing being next. We do have one more question that was typed in. Let's see what the question is here. The question, Jamie, this is for you. It says the 2010 NFPA section 110 adopted by reference 2012 NFPA 99 adopted by CMS requires 96 hours of on-site fuel. So that sounds like more of a statement. So Jamie, I don't know if you can gather a question.
I can talk to that. So our code book has identifies 72 hours, and the NFPA 110 requires 1.3 safety factor. So that 72 times 1.3 is the 96 hours. So the fuel, and the idea is that the fuel required for the 72 hours is 96 hours worth of fuel to give you 72 hours of operation. I hope that answers the question. If not, just you can re-up it.
Great, thanks, Jamie. We do have more questions for you. They're starting to come in, so thank you for those who are typing in the questions. Again, if we don't get to your question and not able to answer during this presentation, you will have the opportunity to send us an email over to regsunit@hchi.ca.gov to get your question answered. So Jamie, the question reads, can fuel cells or batteries be used for emergency backup?
As the code stands right now, fuel cells and batteries are acceptable for emergency backup. You'll see in the code that we identify that CMS has their own requirements. That's the Center for Medical Services, which reimburses facilities for Medicaid and Medicare. And currently, CMS does not allow, CMS requires generators as emergency power source. Additionally, we are unaware this time of any fuel cells that have special seismic certification. Those systems that are EPS will need to have special seismic certification, and the 72, I'll say 72/96 hours of on-site fuel storage. So really interesting question. I recommend that if you would like to learn more about this subject, you take a look at the Hospital Building Safety Board, Energy Conservation and Management. The last meeting, we had a deep discussion on emergency sources.
Great, Jamie. We have time for two more questions, and I'll go ahead and read this question, more of a clarification, if you will. The question reads, it sounds like the presenter said minimum 10-second retransfer time for ATS. Should that be a maximum?
Yes, thank you. My mistake.
Great, thank you. Next question here we have, with non-rated cabling in IT rooms, would any existing non-related cabling need to be corrected if doing any work in an IT room?
We're not going to require cleanup of something that's currently not code compliant. If you're starting to put so no. If it's already a dedicated IT room and you're doing work in that room, we're not going to go back and look at cabling and have that rerouted. If you're creating a new IT room, you need to meet this requirement.
Perfect. Okay. Jamie, I want to go ahead and thank you for your time, and I want to thank those that were able to type in the questions into the question section of the GoTo dashboard there. With that being said, we want to go ahead and move on to the next presenter. And I believe the next presenter is going to be Mr. Larry Enright. Again, he is the Senior Mechanical Engineer and Technical Lead for Mechanical here at HCI. Larry, if you're there, the presentation's all yours.
Hello, I'm Larry Enright, Senior Mechanical Engineer, and I will cover Part 4 and Part 5. Next slide, please. So the first change was an addition of a definition for zone. This definition was added to provide the definition for zone, and this change is to specify the meaning of this term within Part 4 and reduce confusion. This definition will coordinate with CMC Table 4A for temperature control requirements. Next slide, please. The next change we had some rearrangement and revision to 407513 of the California Mechanical Code for variable air volume. Let's see, so OSHPD proposes to amend the variable air volume section to specify that a VAV device is required in spaces with pressure requirements. This is to ensure spaces in Table 4A will be provided with necessary equipment to maintain pressure requirements. In these systems, a supply box may be provided with constant volume, but the return airflow can fluctuate. This changes to help keep supply and return differentials throughout the range of operation, and that's as required in CMC 407 5.1.1. Next slide, please. The next change was to add section 407.6 for economizers. And this is to note that or include modulating relief and or return fans to ensure compliance with pressure requirements. So we have two diagrams shown here. One is with just a single fan, and they sometimes come with a barometric relief damper. This can cause the space to be pressurized and lose the CMC Table 4A airflow and tab requirements. So the diagram on the right will show a powered exhaust section, and this is to help keep a uniform supply and then also return airflows from the space. Next slide, please. The next change is to add section 420.0, and this covers air distribution devices. And this is to provide a pointer to ASHRAE 170, and we currently adopt the 2013 edition. And this is for section 672 and table 672. This section will require things such as the non-aspirating diffusers shown on the left. These are for procedure rooms and operating rooms and more of the clean type rooms. This is to provide just a pointer to show the requirement, as these can be costly in design error if they're not caught and taken care of during design. Next slide, please. And here we're doing a cleanup, remove a redundancy on Gamma camera. When we did the last major revision to Table 4A, we had two locations for Gamma camera with different requirements, and we're striking through the second requirement, and we're noting here in purple just shows the language that will stay for nuclear medicine. Next slide, please.
All right, it looks like we've that's the end of the mechanical portion. Moving on to the part 5 plumbing. Larry?
Yeah, and I'll cover part 5. We had a couple changes for part 5. The first change is to provide additional language shown here in blue, and this is to reference the NFPA 99 edition, which is going to be in chapter 80 of the fire code. Sometimes the codes between the mechanical and the fire code don't line up, and I want to make sure that there's a clean call out to get the correct edition. Next slide, please. This is also a cleanup. This replaces a missing exception. This exception shown in blue dropped out of the code, and the previous intervening, we're putting it back in. This exception was to note that for OSHPD 1R and 3 buildings, the central supply source for med gas can be located in there. The charging statement above appears to say that you can't have sources in any building. And then the 1304.12 is an important section, as in we're not allowed to share the med gas directly from an OSHPD 1 or higher, or 2 or 4 or 5 building down into a 1R or a 3. This is due to jurisdictional and or seismic issues. Next slide, please. And lastly, we're adding a reference standard for dialysis. In chapter 6 of the plumbing code, we have the dialysis requirements, and we've called out ANSI AAMI RD62. This is just adding it into table 1701.1 to provide a good reference for the standard. Next slide, please.
All right, Larry, looks like that does it for that section. We do want to go ahead and answer some questions that were typed in the first part, mechanical, and then obviously plumbing. So Larry, these questions are for you. Question reads, for 407.5.1.3, if you have variable volume on non-pressurized required spaces, can you use only one control valve for an entire wing to offset the entire flow changes as not to affect a space, such as a clean room, to not offset the entire floor?
Those will be looked at through plan review and through design. So the previous section did call out in-R spaces. For in-R spaces, we'll evaluate during plan review to make sure that we're also following with other sections of the mechanical code, including the 407, 413, I believe, for use of plenums and corridors and above ceiling spaces, and also filtration requirements for airflows going from room to room. But the intent is to have the designers have a little bit of capability to have a little bit less equipment or boxes on the return side to allow for VAV.
All right, perfect, Larry. Thank you for that. We have a next question that says, are you saying that barometric relief dampers are not allowed for economizers in pressure controlled spaces?
So we're looking at is when the return air is purely pushed out of the building or room with a barometric relief damper, that causes the space to be pressurized and does not meet the intent of the other sections, including with 170, where the airflows are supposed to be maintained throughout the operation.
All right. Next question reads here, Larry, for you. It says, I thought there was a clarification in Chapter 4 that defined more clearly to follow ASHRAE 170-2013.
Let's see. So the general ASHRAE call out in 170 does identify the 2013, and that is in the very beginning of Chapter 4. I believe it's 407.12 or 21.
All right. This is a good question, Larry, for you. This question reads, hot water pipe insulation. Should we follow CPC 609.11 or Title 24 Energy Code?
That is a good question. So that one I'll have to take offline. I have to look at the specific Title 24 Energy Code. There's a lot of sections in the Energy Code that are in there but are exempted from OSHPD. So I could follow up on that one when we're done.
That's a great segue, Larry. And for those of you who have specific questions, feel free to send us an email over to regsunit@hchi.ca.gov, and we can definitely have an offline conversation with you to clarify the issue. Or if you have a specific project that has an interesting situation, we'd be happy to help with that as well. So send us an email over to regsunit@hchi.ca.gov, and we can definitely help you out with that. Moving on to the next question, Larry, and it looks like we're almost out of time for this portion of the Q&A section. The question reads, please clarify 1304, is this meant that an OSHPD 1R cannot be served by an OSHPD 1, or that it requires a separate main to the source?
Yeah, so for the 1R and the 3s, the section looks for a separate tap or main ahead of the main valve. And typically where it's provided with its own pressure regulator, if any breaks in the building will not allow for the hospital to be affected by that loss. So then we would look at allowing those other buildings to be served by the main supply.
All right, Larry, I got two more questions for you. Question reads, for ventilation on OSHPD 1, do we follow the CMC table 420.1 or CEC for outside air required when table 4A does not apply to the space?
So we have a footnote in 4A that actually refers back to 60.1 for other spaces that aren't applicable under 4A if they're not specifically mentioned, which should be mostly non-patient areas. And that is coordinated with ASHRAE 170.
Perfect. Larry, I'm sorry, go ahead.
Sorry, excuse me. There was one other question that asked about the current ASHRAE 170. The 2013 was adopted back in the intervening cycle of the 2016 code. IAPMO is also still adopting for the model code, the 2013 edition of ASHRAE 170. We do look at other editions of FGI and 170 when we're looking for different California amendments to the code, but based on the IAPMO adoption, it's still staying with the 2013 edition.
Great, thank you, Larry. One last question, and this question is specific to the TIO, which has become a very popular item. The question reads, can you speak a little about the new TIO requirement on air balance prior to demo work, and then a second air balance report after the replacement of mechanical equipment, and then in parentheses, water source and heat pumps?
Yeah, so as far as the TIO, there are 3 different sections. Typically, the pre-demo readings are to get an analysis or a benchmark of what the existing system has, especially for areas that are not going to be a part of the project scope. So we can get a benchmark for areas outside to measure and maintain. The post-demo work is typically because if ductwork is capped, you're reducing airflows in the system and you're affecting the air balance to adjacent areas. So the post-demo is to measure and maintain areas that could be affected by the demo work. And the third is the final air balance to bring everything into current and measure and maintain.
Perfect, Larry. Thank you for that. I do want to mention that we are out of time for the Q&A section for the mechanical and plumbing. So if you do have a question that we did not get a chance to answer, send us an email over to the regs unit email that I've mentioned before. So moving on to our next section of this presentation, we're going into the California Building Code Part 2, Volume 2. And for that, we're going to have Mr. Roy Lobo. Again, he's a principal structural engineer here at HCI.
Okay, good afternoon, and thank you, Cesar. Looks like we have a little bit of extra time here, so I will go easy and slowly enough. Hopefully everybody can understand. Now, I'm going to be talking about the structural changes, structural amendments to the 2022 California Building Code. For those of you who are not totally familiar with the process, we start with the 2021 IBC and all the reference standards. We then take that as the base document, and then we include the amendments that we previously had from the 2019 California Building Code, and then we add on new amendments or make changes based on what we see, depending something's changed in the reference documents, then we need to modify those, and then we combine all of that, and then that forms your 2022 California Building Code that you're seeing. We have made changes in both the non-A chapters, those for OSHPD 1R, OSHPD 2, and OSHPD 5, and then also to the OSHPD 1 and 4 in the A chapters of the California Building Code. Next slide. Okay, next. Okay, so these are the reference standards from the IBC that were not updated when they moved from the 2018 IBC to the 2021 IBC. So the good news is AAC 716 is still going to be the reference document for the loads in the 2022 California Building Code. And for those of you who have been keeping track of the code changes that have been happening in AAC 722, there's a big code change coming for non-structural components. Good news is that is not going to come till the 2025 California Building Code, won't be adopted till then, so you still have some time. We did not make changes, there were no changes to the specifications for structural steel. So those remain the same. AISC 360 and AISC 341, those remain the same. MDS, we kept it at the 2018 version, and masonry was the 2016 version. So those remain the same. Next slide. These are the reference standards that were updated. ACI 318.14 now became ACI 318.19, and there was quite a bit of changes there. We will be talking about some of those that affected our amendments. Also, the SDPWS, sometimes pronounced as SPIDWIS, that's your wood shear walls and diaphragms, your seismic design for those. So those for wind and seismic. So that one has been updated to the 2021 version of the SPIDWIS. And then the AWS, only the structural welding code for steel reinforcing bars has been updated in the 2022 building code. The others remain the same as they were in the 2019 building code. Next slide. Okay, so now moving on to part 2, volume 2, the HCAI amendments or the Oshport amendments. There were major changes in chapter 16, 16A, 17, 17A, 18, 18A, 19, 19A, 21, 20, 21, 22, and the reference standards. So I have mentioned that, you know, A and 16A and 16 and 16A, for example, I will be only mentioning one of them. If the changes are replicated in both, then you know, you will just have to see the appropriate change in the A section of the code. But the change, we will be talking about the change, so you concentrate on that, and the reference section, you know, you will have to check. So next slide. So chapter 16 and 16A. So as I said, we will only be showing the reference, the code reference for made in the non-A chapters, and then you will have to find the appropriate code reference in the A chapters. So now a change was made in the 2021 IBC, where they now referencing the load combinations in AAC 7. However, they retain the alternate allowable stress design load combinations, and they forgot to add in this last section, last line at the bottom. Each load combination shall be investigated with one or more variables load set to 0. But this language was there in the 2018 IBC. It was somehow deleted in the 2021 IBC. But this language is also there in AC7. So it appears to be an error. So we decided to put it back. If somebody wants to use, it's typically not used much, but if somebody wants to use the alternate allowable stress design load combinations, then you need to check your load combinations with some of the variable loads, with the other variable loads set to 0, so that you can get the maximum load effect on your structure. Next slide. Did we just lose it? Okay, next slide.
Yeah, I apologize. My computer is going a little wacky here.
Okay. All right. So now, if for those of you who recall, there were some changes made to the FA and FV tables in AC 716. Now these changes were made to accommodate the change in the long period spectrum, you know, for basin effects, etc. So we were not getting the full magnitude of the ground motion, the long period spectrum of the ground motion, and so there was some. So to adjust for that, they made changes from the 2 period spectrum to FA and FV values. So it took a couple of supplements. So in supplement 3, those issues that were caused by this change in the FA and FV tables in the AAC 16 code, those were corrected in supplement 3. So all we have done is taken the language from supplement 3 and added it in these tables within CBC 2020, in the 2022 CBC, in the appropriate tables, table 1613.2.3 for the FA value. And then the next slide is the same, is also the change taken from AAC 716 supplement 3, whatever that changes to the FV tables, and that is also being put now into the 2022 building code. So now you can create your response spectrum based on your ground motion map. So that was the change that was made. I mean, it's now hopefully it's easier to use the code to get your SDS and SD1 values. Next slide. What we also did was we also now permitting the use of the multi-period spectrum that is now there in the 2020 NEAR provisions. It is also there in now permitted in the AAC 722, but 722 will not be adopted till the 2025 CBC. So we did an early adoption of using the multi-period spectrum. So instead of doing your site specific ground motion for S sub 1 greater than 0.2, you can also use these, or use the exception, which is multiplying by 1.5 times the spectrum values. So you can also use the multi-period spectrum. And but if you're going to use the NEAR 2020 multi-period spectrum provisions, then all the other requirements, so we have your requirements 1 through 8, also all of those have to be followed. So so you cannot just pick and choose. You have to make sure that depending on what you're going to use that multi-period spectrum for, you need to follow all these other requirements as well. Next slide. This is we did some early adoption of some of the requirements that were coming in AAC 722 and we put them into our amendments in the 2022 building code. And this is this requirement is in section 1617 8.1.5, modifying section AAC 7 section 12.2.3, where if you're having seismic force resisting systems that are in the same direction but that are different, then the most stringent R value will apply to your design. So unless it is a dual system. So dual systems are not will be whatever the R value for dual systems, but if you have different force resisting systems in the same direction, then the most stringent one will apply. Next slide. We made some changes to the two-stage analysis procedure. Again, this is an early adoption of whatever requirements are going to be coming in AAC 722. The first one is in item A. This language is basically a clarification on how to calculate the stiffness of the upper portion and the stiffness of the lower portion in order to define whether your analysis qualifies for a two-stage analysis procedure. So we made sure that, so because there was some confusion in how to calculate stiffness, and there were different ways to do that. And so now we've added in the language that was already balloted at the time and accepted in AAC 722, and we said we're going to use that same language here. So now so then the designer has an easy way to know, okay, and consistent for us to also prove what, okay, this is the way you will calculate your stiffness of the upper portion. This is the way you calculate the stiffness of the lower portion, and check whether your stiffness is for the lower portion is 10 times that to qualify for that. So that was the change there. Next slide. Then the next change was item F. Item F, we do not adopt that, but that item F basically states that the new change, I mean, this is an AAC 722, which was saying that if you had a two-stage analysis and your height limits for the upper portion of the structure was it can now be calculated from the height of the base of the upper portion. So we said that limitation we do not accept. So it'll be whatever your building limitation for that particular type of structure is there, that's the same limitation we will have for us. Then for item number G, if your building had a horizontal irregularity type 4, that's the figure at the bottom, or you had a vertical irregularity of type 4, that's the figure on the right, on the bottom center and the bottom and the figure on the right. Then you have to make sure that you will have to also amplify the demands coming to that lower portion with the appropriate sections. We have identified those sections here. So just to make sure that those amplifications, if you have any of those irregularities, do not get missed in your design. And then we said these are the amplifications that you will have to do, and then addition to the amplification required by item D. Item D was basically your R over rho. So you change an R from your upper structure to lower structure. You will have to do that in addition to any of this. So it is something that you don't want to miss. Next slide. This one is an amendment that we had created and I think it was in 2019 Building Code. That was exception 1. This is for buildings that had extreme torsional irregularities. So we are going to permit buildings having extreme torsional irregularities under certain situations if the deformation in the direction of the irregularity was less than 10% of allowable. So that was the existing exception that we had. And then there was a new exception for these irregularities we permitted, which is coming in AAC 722. That's the exception number 2 in blue. So we decided to add that and that as well. So if you have prohibited irregularity for torsion, this is basically for the torsion irregularity, even though it says it permits for other irregularities. It is structures having a horizontal structural irregularity type 1B of table 12.3-1 are permitted, provided the redundancy factor rho of 1.3 as defined in AAC 7 is assigned to the seismic force resisting system, both orthogonal directions. So that has to be done. So but if you use, that exception is different from exception 1. So exception 1 and exception 2 are a little bit different, but we decided to keep both of them. Next slide. This is a requirement for differential settlements. So AAC 7 section 12.13.9.2 requires for buildings in risk category 4 that the demands on members and connections should be checked for differential settlements. And then we also clarified that if you're doing the differential settlement check, there's the figure on the top, you do not need to also apply the seismic loads and the differential settlements in the same check. So they are 2 independent checks. So hopefully that's a little bit of a break. Next slide. Okay, now I don't know if it was in 2019 code or 2019 intervening code cycle that OSHPD added in a number of requirements for equipment anchorage, where we added in the fixed, movable, mobile, countertop equipment, etc. And we gave the specific requirements on how each of those equipment need to be anchored. And then we had exceptions. So exception if you have your building weighed more than 400 pounds, if your equipment, excuse me, if your equipment was less than 400 pounds sitting on the floor, or your weight was 20 pounds or less from a wall or hanging from a roof, and for distributed systems less than 5 pounds. But there was some questions based on that, because it was not specific to an equipment on a wall. And they said, oh, what happens to an equipment on a wall that weighs more than 20 pounds? What are we going to do for that? So do we need to again show the anchorage and details on the CALs? So we decided that yes, you do. It's not without proper anchorage. It's not going to stay on a wall or hang from a roof. So we put it there as also equipment that is weighing more than 20 pounds. You'll have to show the design and details on the drawings. Next slide. Okay, so this is for design of elevator guide rail supports and retainer plates. Now, when they switched from allowable stress design to strength design in the building code, then the minimum requirement for design of your elevator guide rail supports was based on your 0.5 G. The maximum seismic force shows 0.5 G was the minimum that you had to design your elevator guide rail supports for the retainer plates. But by transferring from allowable stress to strength design, that 0.5 G remained the same. So what was the force was that allowable stress design was now being under-designed when you moved from allowable stress to strength design. So we just clarified that that value, that the 0.5 G was in the building code, is the allowable stress design load. So if you're doing strength design, then you need to amplify it for the appropriate factor. Next slide. ACI 31819 has now a new section on shotcrete, and in that they've also referenced the specifications, ACI 506R on how you would need to do mock-up panels and all the specifications for shotcrete. Now, that language in ACI 506R is not written in mandatory language. So even though you saying you follow ACI 31819 and the shotcrete requirements there, it's not 100% in mandatory language. So people may say, oh, it's optional. So for pre-construction tests, so these are your mock-up panels for shotcrete. So we've added in that section 1705.3.9.2. What are the requirements for your mock-up panels? And we've written it in mandatory language. So that is what you're going to see in that section of the code. And in the top it says chapter 17 and 17A. So it's applicable to both. Next. This is a requirement for glue laminated timbers, where special inspections need not be done, provided that those glue laminated timbers are prismatic, and you have identified it on the drawings that it's sourced from stock or general inventory, and it is of 5.5-inch maximum width and 18-inch maximum depth. So part of the requirement was already there, but we just clarified that it now needs to be identified on the drawings that those glue lams should be sourced from stock or general inventory. So unless it's done that, and it also has to be prismatic, otherwise special inspections for glue laminated timbers would be required. Next. Okay, these are the load testing for helical piles. This is in section 1810.3.3.1.9. It says that ultimate capacity determined from load tests were required by section 1810.3.3.1.2. So we've made an amendment there, and we said load tests are required to determine ultimate capacities. And this is applicable in both chapter 18 and 18A, even though the section reference here is only 18. So next. This is for precast concrete piles. Now, a lot of the provisions in ACI 31819 have been for precast concrete are now included in there. So, the IBC then said precast concrete pile design in accordance with ACI 318, and then they have an exception where you said the minimum volumetric ratio for spirals or circular hoops need not comply when if those loads are for the overstrength factor. And those are not being permitted. So you would still need to check the volumetric ratio for that. And then we've added on our initially existing amendment to that and said that the limits to which the axial load from seismic forces is applied with the overstrength, those may be increased 2 times what the existing values were. So those may be increased twice, but you still need to put reinforcement to meet the volumetric hoop requirement. Next slide. This is when you have your piles that require to resist tension, and you have your deep foundations. You need to anchor the reinforcement connect the reinforcement to the pile into the pile cap. So there is an exception in the IBC which states that if you are designing it for overstrength and your system is still stable, then you do not need to have your pile rely on the tension. No, you do not need to design your reinforcement and connect your reinforcement of your pile into the pile cap. So that means if you have an omega overload, you can have a separation between the pile head and your pile. So we said that is not permitted by OSHPAR. Next. If you're designing your grade beams with the overstrength factor, then you said you need not comply with the confinement requirements of section 18.3.3 of ACI 318. Next. Okay, so this is section 1811, pre-stressed rock and soil foundation anchors. So in the latest version, or sorry, the current version that we've adopted of your PTI manual, in that version, there is a requirement for, they've added in a new time frame called extended temporary, which goes from 2 years to 5 years, for which your anchors can be considered extended temporary. So we clarified that if you're going to have your temporary anchors longer than 2 years, then you would need to have corrosion protection of class 1, right? So only up to 2 years you can consider your the corrosion protection for your anchors as temporary. If it is more than 2 years, then you would need to have your corrosion protection as class 1. So we just made sure that people are aware of that the temporary doesn't go beyond 2 years. Okay, next slide. This is the same requirement for extended temporary, which is from 2 to 5 years. So even those will use a class 1 corrosion protection. This is for earth retaining shoring. It's the same requirement for corrosion protection. Next. Okay. We modified the amendment for freestanding cantilever walls. Previously, freestanding cantilever walls we were designing using Chapter 13 of AAC 7. Now it is going to be designed by Chapter 15. So freestanding cantilever walls shall comply with Section 15.6.8 of AAC 7. DSA didn't adopt it, but we continued with our existing amendment regarding a stability check. But what we did was we deleted the requirement where your RP value was to be divided by 4 for the stability check. So we just deleted that because now we're going to Chapter 15, where there's no RP value. Next slide. This is for vibro stone columns. This is for ground improvement. So if you're trying to improve your ground, we said that before you can actually do the start of your foundation work, you need to have a verified report stating that the ground improvement has been done and giving you the soil capacities that you are expecting. from it before you starting pouring your foundation, because once you pour the foundation, it's too late to then, it's too expensive. So we said, make sure that this is not missed. We've added in a requirement that a note on the drawings needs to be added, that you would need to do this before you start your construction. Next. This is for tension testing of anchors that are not going to fail in a seismic event or a hazardous event like wind, etc. So if you had non-structural components, this is for state detention and correction. If you had like your grab bar or a shower seat that in natural disaster like seismic or wind, etc., you are not going to fail these items. For those post-install anchors, tension testing is not required. Okay, so that's just clarifying that requirement for tension testing for things like grab bars and shower seats, which do not cause a life safety issue or a failure during an earthquake. Next slide. Okay. Now, this requirement was there for tension testing of anchors, where we had to make sure that the cone, the resisting cone of the equipment that you're going to test your anchors was greater than 1.5 times the 1.5 diameters. So you are around the breakout cone. So you want to make sure that you do not inhibit the breakout cone when you're doing your tension test. So your anchor support locations should be within 1.5 times the anchor embedment depth. Now, we said this requirement need not be complied with if your breakout cone is not going to be a concrete failure breakout cone, and if it is going, if you have adhesive anchors that are dependent on bond, and you're checking for bond, in that case you can have your apparatus that is doing the tension testing closer than the 1.5 anchor embedment depth. So we made it a little bit easier for adhesive anchors for testing other than concrete breakout, and you're testing for bond. So next slide. ACI 318 section 14.1.4 is for plain concrete. So we said plain concrete is not permitted in seismic and design categories D, E, and F. So that includes all of HCI buildings. Next slide. As I mentioned, the ACI 318.19 now has requirements for shotcrete. So the requirements in section 1908 of the IBC has now been stripped away. So we have to then put our own amendments back in there. But this is a new amendment that OSHPD has added in. So when you're evaluating your shotcrete mock-up panel, you have to make sure that the core quality of your core that you're taking out from that is in good or very good condition to accept the cores from your mock-up panels that you're going to do for shotcrete. Next. This is just a pointer back to section 1705A.3.9.2, which tells you how your shotcrete panels, the mock-up panels, will be constructed. It should be constructed in the thickest area of the concrete with the most dense reinforcement, and make sure that the whoever the person going to shoot the shotcrete into the shotcrete panel, does it right, and you can get the appropriate cores and they meet the requirement strength. So this is just a pointer. Next. 318.19 then changed the maximum tensile strain limit from 0.005 to now epsilon ty plus 0.003. So our existing amendment, we had to modify this table, and we had to modify existing amendment to match that maximum strain limit. So it's a very minor change. Next slide. Again, this is for your minimum flexural reinforcement in your foundation. You said there was a requirement where you had to do it like 4/3 the required amount of steel, and therefore you do not need to achieve your minimum flexural steel requirements for your foundations. We said that is not permitted except under these conditions. So you can, if it is for foundations of 1-story wood or light frame buildings, or your foundation is designed including the requirement for overstrength factor, and then your AS provided is not less than 1.2 times the cracking load. So we've just adjusted the minimums for the foundations, and these are the requirements for that. Next slide. Okay, there were big changes made to the masonry chapter based on public comments between, and then also collaboration between OSHPD and DSA, and then it was a major rewrite of basically chapter 21A. That was a major rewrite of that chapter, where we took our existing amendments, and then it's going to, so the new amendments are going to look very different. And so now you have to reference the TMS 402 or 602, and then our amendments are taken as modifications to the TMS 402 and 602, so that we don't have duplicate language in the masonry chapter, in our amendments, in the OSHPD amendments, and conflicting with the reference TMS. So that was a big effort, and so you're going to see a lot of changes in especially if you're used to certain language in your 2019 CBC for masonry. It's going to look a lot different in your 2022 masonry chapter 21A. And then 21, we also use the same amendments that we did in 21A. We put them in 21. So I'm going to mostly show you the ones in 21, and the 21A will be similar. So next slide. So this is 2103.4 for metal reinforcing and accessories. This is for when you have identified unidentified reinforcement. And we also said, or bar reinforcing without MIL certifications, then you need to do certain tests. And we said, and then our existing amendment for alternate frequency of sampling of unidentified reinforcing can be done per section 1910, that is the concrete chapter. So it's all we just added on was bar reinforcing without MIL certification for unidentified reinforcement. Next slide. This is in chapter 21. It's going to look different in chapter 21A. This is basically the when you're cleaning out your placing of your mortar units, you clean out the masonry protrusions. The TMS allows you 1/2 inch. Our amendments were 1/4 inch. We just kept our same amendments there, and so that was the change from 1/2 inch to 1/4 inch. Next slide. This is requiring the gap between your reinforcement in your grouted cell and the face shell, and then this is our existing amendment, which will be minimum of 1 bar diameter. That's what you need. So you have to make sure there's sufficient mortar around the reinforcement. Next slide. So this one is for the headed anchor bolts. Again, the same requirement where you need a minimum amount of mortar around the bolt, and so the bolt is not flush against the masonry unit. So we just added in that requirement in there. Next. Okay, these are for a mortar and grout test. So depending on if you're going to do your mortar and ground tests which will be based on proportions or is based on property, then this section just identifies the appropriate ASTM standard that you need to use to check your check your proportions are appropriate and your motor for proportions are okay, or if it is based on property, then the different ASTM standard is shown for that. Okay, next. Okay, so masonry prism testing and units masonry unit strength method, those are being deleted because now we are going to go directly to reference standards. So we didn't want to then duplicate the same language in our amendments, which is already there in TMS. So we are trying to now encourage people to look at their TMS rather than look at amendments for all the changes. And we are now making the changes more as modifications. So if it's the same language in the TMS, we deleted that requirement in the code. So it's not that you're not going to do masonry prism testing or unit strength method testing. It's just that you got to look in the TMS for that requirement. Next slide. Masonry compressive strength. Previously, it was a minimum of 2000 PSI. That we have lowered from 2000 to 1500 PSI. So you are allowed to design masonry with the strength of 1500 PSI, and then your design needs to be adequate for that. So that was the main change there. The rest of the changes were just relocated sections that were existing amendments in our 2019 code. Next. So yeah, this is the similar language. One was for allowable stress method, and this is for strength design method. So that I think was 207. This is 208. Again, we are permitting masonry stress to equal or exceed 1500 psi. Next. This is on for cold form steel light frame construction truss design. The amendment was somehow deleted. It was an existing amendment that was missed in the 2019 CVC code. So we just added that amendment back. This is regarding a complete engineering analysis and truss design drawing shall accompany the construction documents submitted to the enforcing agency for approval. So this was not a change really. It was more like an errata that is added on. Next slide. Okay, right. Questions? Yeah.
We have opportunity to answer questions from the attendees. So if you haven't had a chance to type in your question into the GoTo dashboard question section, go ahead and do so while we ask the first question here. Roy, the first question is, can you confirm the limit for hung equipment of 5 pounds per foot should be 5 pounds per foot or 5 pounds per square foot?
It is 5 pounds per foot, linear foot. So exception only if it's weighing, if your distributed line is weighing less than 5 pounds per linear foot, then it's exempt from bracing requirements. You need to hang it, but it's still exempt from bracing.
Great, thank you for that, Roy. I'm going to go ahead and give the attendees another chance to type in the question in here into the question section. So we would like to ask this question. Let me read this question over. It says, following Roy's presentation, here are a few comments for the structural engineers that are attending. This webinar may be considering use of multiple period responsive spectra per the 2020 NEPRA provisions as an alternative to ASCE 7-16. So that's more of a comment. So if you have any other questions that we can go ahead and read here to the general attendees list, I would be happy to do that. So I'm gonna give it one more minute, and if not, we can move on to the next section, Roy, if whenever you're ready.
Okay, as you said, give a minute to see if somebody had a question, and if not, let's move on. Looks like we'll be finishing a little early today.
Yeah, we will be. We're a little ahead schedule, so that's good. I want to take this opportunity to remind you, the attendees, that if you do have a question that maybe you think of after the presentation, after we end today's presentation, you can send that question over to the regs unit and we can go ahead and evaluate the question and send it to the technical lead, whether it's electrical, mechanical, plumbing, or structural, and we can definitely get back to you with a good answer for your question. We do have a question, Roy, for you. The question reads, for new evaluations of HSOcrete panels.
Shotcrete, basically for shotcrete panels, yeah.
You mentioned that they need to be good or very good.
Mm-hmm.
Can you clarify that?
Yeah, so that level, and the thing is, we've given the reference section. I think it's 506.4 or something. Whatever. If you when you get the handout, the reference to the section you got to see clarifies that. So I don't remember the top of my head what that is, but that's given in that reference section that is mentioned there in the code.
All right, very good. Thank you, Roy, for that. I'm going to go ahead and give you an opportunity. One more question, if any, if you go ahead and type it in. If not, we can go ahead and move on. So I think it's safe to say we can move on, Roy, if you're ready.
Yeah, go ahead, move on.
All right, here we go. Going on to the existing building code, part 10, Mr. Lobo.
Okay, so I'm just going to read this first part. International Code Council renumbered much of part 10, which basically is the IEBC. Renumbered much of part 10, which affected a lot of our previous code. So you will see a lot of changes. If you look at our express terms, it looks like a lot of changes, but it is mostly just renumbering to match the numbering given in the 2021 IEBC. So much renumbering occurred along with pointer corrections. We're not going to include that as part of this presentation, but we just wanted you to be aware of it. Next slide. Okay, so we did make some changes, I think, in the 2019 intervening code cycle. This is for buildings that are going to be upgraded from SPC 1 or 2 to SPC 4D, where we said that if you had an adjacent building issue, where you had to evaluate a building for pounding, what would the requirements be? So we made some revisions back in the 2019 intervening code, but the location where we made the revisions, were not the exact location that we wanted them to be. So what we did now, we took this opportunity to rewrite those provisions with that intent, and those revisions are now being brought forward into the 2022 part 10, California Building Code part 10. So so that's basically what it is. It's saying that if your building was not less than half as tall, that those stories match up, then you did not have to do a pounding analysis for structural performance levels that were lower than life saving. That means for collapse prevention, you didn't have to do anything. You still had to need to check it for damage controls under certain conditions. Next slide. Yeah, so for checking your adjacent building deficiency, you would have to, for damage control, you would have to see if your adjacent building, was more than 2 inches times number of stories. This was the same requirement there in the California Administrative Code, so we decided to add that in so that it made it easier. We just clarified the language, made it easier so that people know what they had to when they're checking the adjacent building deficiency. And then the existing amendment that was there, where you have to check your adjacent building. If you didn't meet the other exceptions and you had an adjacent building deficiency issue, then what you would need to check that adjacent building for, and then when you would need to evaluate like both buildings with pounding analysis, if you did not meet the adjacent building check in your CAC, which is now, that language is now been incorporated into this section 304A. Next slide. Yeah, so basically this graphics basically explains, when you would have an adjacent building deficiency or not. So if your building gap was greater than 2 times number of stories, then your height check is okay, and you don't need to do any other check. So then you're good to go. So you don't have an adjacent building deficiency, and you can upgrade your building SPC 1 or 2 to SPC 4D. Just looking at that main building is your building, you're going to upgrade to SPC 4D. Then if your gap is less than 2 times that, then you go ahead and you do your height check, matches, floors matches. Exception is allowed, but you still have to check your other building for any of those other deficiencies that we showed in the previous slide, and for damage control. And if they're okay, then you're good to go. If your gap is greater than 2 times and you're less than half as tall, or the floors don't line up, then again, you are no good. But if your gap is more than that, then again, you don't need to do any check. If you're, but for collapse prevention, you would need to check the gap. And then if your gap is less than 2 times number of stories, then it shows you what you would need to do. In that case, you would have to check the pounding analysis for the main building as well. Next slide. So this is modifying requirements again for SPC 4D or the foundation chapter in ASC 41. So we made some changes to how the acceptance criteria for the foundation bearing capacity is going to be checked. Now, if you go into ASC 41, chapter 8, and try to figure out, or this is ASC 4113, because the SPC 40 is specific to ASC 4113, and try to figure out the acceptance criteria for foundations, it was quite complex, because all they did was looking at your moment capacity for a single isolated footing. And we have buildings on complicated foundation plans, and using the acceptance criteria in ASC 4113 or even 17 was kind of a challenge. So we modified it and added some alternative language. Next slide. And then we said that you can permitted to take your pseudo-seismic force demands from ASC 41 and divide it by your M factor for your performance level. If it is damage control or if it is collapse prevention, the different M factors. You can take that demand, divide it by the M, and do it like the way you normally do your foundation check in using you're designing a new building. You take your demands from your fixed space analysis, you put them in SAFE. But here, this is not the demands from a fixed space analysis. This is the pseudo force demands. So what happens is that means you get instability when you try to check it with a program with SAFE, where your soil does not resist tension. And so there was kind of an issue there. So we just clarified what the requirements are. If you want to do that and you want to continue the way you've been doing similar to ASC 7, then we have then given you how you're going to do that. And so we've added new language for that. Next slide. So this is what it shows you, what your soil pressure under your footing will be under increasing demand. So your overturning moment, you get to divide your overturning moment by an M factor, and that changes your profile under the footing. And then if your maximum pressure Q, that is your bearing stress under the footing, is less than your upper bound value for your allowable prescriptive values for soil bearing pressure, then you're okay. And this one just shows you like the different shapes of what your soil pressure diagram is going to look like, for an individual footing if you increase the demand, so till you get instability at the top left-hand corner there. Next slide. This is your foundation acceptance. If you had a combined footing, you can now just use your pseudo force demands divided by your M factor, and then you can then use the maximum soil bearing pressure as your check. If it is less than your ultimate soil bearing capacity, then you're good. So this makes it easier to check your foundations for soil for your soil bearing strength. So hopefully this is an improvement on what is there. There are some further improvements that's coming in your AAC 4123, but they're not here yet. And when they happen, then we will include those in our amendments. Next slide. So what you saw before was the requirements for foundations modeled as fixed base, foundation interface model as a flexible base. It's the same. We made the same change. Next slide. So we again allowed the alternate method by which you're allowed to take your pseudo force divided by M and then check your foundations. Next slide. Now that is checking for soil bearing capacity and your resistance of your soil to your demands from your superstructure. But then we also made a slight change to how you will evaluate your foundation component itself. And we've added an exception where you'll still design your foundation as force controlled. However, if the action on that foundation, like if it is a flexural action that is a deformation control action, then you are permitted to use expected strength for that foundation. You don't have to use your the lower bound values. So we are still keeping it checking your foundation as a force control element, but you can use expected capacities, which gives you quite a bit of a break on your foundation structural component. There are additional changes happening in AAC 4123 on this particular issue. So just stay tuned on that. Okay, that's all I had. I think that's the next slide is questions.
All right, that concludes that portion of the presentation. We do want to go ahead and remind everyone that if you have not had a chance to download the handouts for this presentation, go ahead over to the GoTo dashboard under the handout section and access the PDF copies of this presentation for your use. There's a lot of great information. If you are unable to download the handouts and are having issues, feel free to send us an email over to regsunit@hci.ca.gov. Again, that's regsunit@hcai.ca.gov. Again, that's if you'd like copies of the presentation, or if you have a question that you didn't get a chance to ask, or we didn't get a chance to answer your question and you did type that question into the question section of the GoTo dashboard. Want to go ahead and remind everyone that we do have session 2 and session 3 coming up. Session 2 of this series is going to be held on October 27th of this year, which we're going to cover building code and fire code. And then session 3 is going to happen on December 1st, 2022. And we're going to cover the California Administrative Code and Part 2, Volume 1, Architectural of the CVSE updates. If you would like to jump onto our website over to hci.ca.gov, go to the Building Safety and Finance, Training and Education, under Webinars, and upcoming, past, and webinars, where we have links to the registration portal for you to attend these webinars. We also have put that link, I know the long list of hyperlink, into the chat section of the GoTo dashboard there. So go ahead and click that link. It's going to take you directly to those registration portions for Part 2 and Part 3 of this 3-part series. Again, so we're going to have session 2 on October 27th, and we're going to have session 3 December 1st. So if you have a question, send us an email, please. We'd like to hear from you. We'd like to answer your questions if you're having difficulties out there. We'll try the best we can to help you out. Over to regsunit at hcai.ca.gov. Again, that's regsunit@hci.ca.gov, and we can send you some more info if you'd like. That's all I have. I want to go ahead and thank the presenters for presenting all the great information. It's been a pleasure, Roy, Larry, Jamie, and I want to go ahead and let you know that it's been a pleasure being with all of you today. Thank you for doing what you do and doing your part in providing access to safe, quality healthcare environments throughout the state of California. Until next time.
Thanks.